The Constitution of India. Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. As I told you before, we have completed the 5th chapter, States of Matter, but the next 2 chapters are not been proceeding to our 12th standard. We don't have those topics, so we can look at those topics a little bit later. We'll be getting into the most important topic which often you have learnt in your 10th standard, and the lesson name is Redox reaction. Redox reaction, which is a combination of reduction and oxidation reaction. We have been hearing this redox reaction from our 10th standard. Even from our 9th standard, you have learnt that oxidation, reduction taking place simultaneously. They are called as redox reaction. Now, redox reaction happens in our daily life in many processes. The first page in your textbook just cites you the examples where it is being used in our daily life, like metallurgy process, pharmaceutical process in making the drugs, and in biopolymers. Wherever we look into burning of fuels, whatever we do there, everything is oxidation and reduction. Without reduction, oxidation cannot occur alone, or without oxidation, reduction cannot occur alone. So, these are the important reactions that we have been learning in the redox reaction till now. Mechanism of redox reactions. A redox reaction involves the oxidation, that is the loss of electrons from a chemical species getting oxidized, and a reduction reaction where there is a gaining of electrons by a chemical species to get reduced. The species which lose electrons will act as a reducing agent, and the species which gain electrons will act as an oxidizing agent. Redox reactions involve the transfer of electrons between two chemical species, and the reactions responsible for the transfer of electrons in a redox reaction are oxidation and reduction. Let us now understand the mechanism of redox reaction through a small experiment. Here we have an electrochemical cell where an electrical energy is generated through a chemical reaction. The apparatus setup of an electrochemical cell consists of two beakers, beaker A and beaker B, where in beaker A, a zinc electrode is being immersed into a zinc sulfate solution, and in beaker B, there will be a copper electrode rod which will be immersed in a copper sulfate solution. A acts as zinc electrode half cell and beaker B acts as copper electrode half cell. Now there is an U-tube which is being inserted, immersed into the two beakers, which will act as a salt bridge. This is to maintain the electrical neutrality between the two solutions. The salt bridge is made up of potassium nitrate solution, and there is cotton plug which is inserted at the ends of this glass tube. The zinc electrode and the copper electrode is being connected to an ammeter through insulated copper wire. Here at the zinc electrode, zinc loses electrons and becomes Zn2 plus, and thus the zinc 2 plus will get into the solution of zinc sulfate and the concentration increases. And these electrons from the zinc electrode, as it passes through the external circuit, the weight of the zinc electrode decreases. And when it passes through the circuit, it reaches the copper electrode or the copper sulfate solution, whereby the copper 2 plus in the solution accept the 2 electrons and get reduced to copper atom. The copper atom get deposited at the copper electrode, thereby the weight of the copper electrode increases. And hence the reaction can be written as zinc plus copper 2 plus giving Zn2 plus plus copper. So here zinc loses electrons to get itself oxidized, so undergoes oxidation, and copper 2 plus gain 2 electrons and get itself reduced to copper atom, thereby reduction occurs. Zinc getting oxidized acts as a reducing agent, and copper 2 plus in the solution getting reduced will act as an oxidizing agent. Those examples you can just go through in your textbook right from the first page, and we will get back into the exact definition. How should we define a reduction and an oxidation reaction? Now here I have just put a comparison of oxidation and reduction reaction for us to understand in a better way. So this will give you a complete information about how should we learn about reduction and oxidation reactions. First, oxidation. Oxy is nothing but oxygen. Dation, getting added. So the first definitions, here are some of the 4 definitions which will help us to learn about oxidation and reduction reaction. So first one is addition of oxygen. What is addition of oxygen? The oxygen atom get added to an element or a compound. That process we call it as oxidation. So here if you can see, magnesium reacts with oxygen to form magnesium oxide. So here oxygen getting added to the magnesium metal, and thus magnesium oxide is formed. Similarly, methane burns in the presence of oxygen, where oxygen gets added and it forms carbon dioxide and water. This is one of the combustion reaction which we have learned in our 10th standard. If you see these 2 reactions, the oxygen atom is getting added to the element. Such a reaction is the addition of oxygen, which is the process of oxidation. If you see the reverse of it for reduction, here when oxygen is getting added, it is oxidation. The removal of oxygen is called as reduction. How can we remove the oxygen? You can see here mercuric oxide, HgO, when it is heated, it gives mercury metal plus oxygen gases evolve. So the oxygen is removed from this compound, and thus the removal of oxygen atom is referred as reduction. Now not only addition of oxygen is called as oxidation. If you see the second reaction in methane, the hydrogen atom is removed and the oxygen atom is added. So how can I define it again? In other words, I can also say that removal of hydrogen is also my oxidation process. So an example you can see here, hydrogen sulfide H2S, when it combines with oxygen, it forms sulfur and water, where from H2S, hydrogen H2 is removed. So removal of hydrogen is also defined as oxidation. So what should be reduction? When removal of hydrogen is oxidation, addition of hydrogen will be reduction, the reverse of it. So here this is an addition reaction which I would like to recall, which we have learnt in our 10th standard, children. Unsaturated hydrocarbons undergo addition reaction to become saturated. So CH2 double bond CH2 is ethene. When it reacts with hydrogen, it forms ethane. So this is a simple addition reaction where hydrogen is being added. So that is called as reduction. So when we talk about oxidation, that is oxygen element or oxygen atom, it's an electronegative atom. So when we talk about electronegative atoms, addition is being added, that is oxygen is being added. Why can't we put in other words like addition of electronegative elements? Because when oxygen is getting added to an element or a compound, definitely it is getting added to an electropositive element. So addition of electronegative elements like oxygen, it can be fluorine, it can be chlorine, it can be sulfur. Any addition of electronegative element to an element or a compound will also make the process of oxidation. So which I would say magnesium plus fluorine gives magnesium fluoride. So fluorine being electronegative get added to magnesium forms magnesium fluoride. So when addition of electronegative element is oxidation, removal of electronegative element will be reduction. So if you can closely see this reaction, FeCl3 plus hydrogen gives FeCl2 plus HCl. There are 3 chlorine atoms out of which one is removed. So you have only 2 chlorine atoms in the product. So removal of an electronegative element. The last one is removal of electropositive element. When I say hydrogen is removed, it is electropositive. So here potassium ferrocyanide, when it reacts with hydrogen peroxide, K4 becomes K3. One electropositive potassium is removed from the reactant and thus we get K3FeCN6 plus KOH. So when removal of electropositive element is an oxidation reaction, addition of electropositive element will be a reduction reaction. Closely observe the reaction. HgCl2 plus SnCl2 gives Hg2Cl2, where there were only one mercury atom, it became 2. So one more electropositive element has got added and thus this is a process of reduction. So these are some of the definitions in which I can define oxidation and reduction. So to put in simple words, I can say oxidation refers to addition of oxygen or removal of hydrogen or addition of electropositive negative element or removal of electropositive element. What is the reverse of it? Reduction can be defined as removal of oxygen or electronegative element, addition of hydrogen or electropositive element. So together we call it as oxidation, reduction as redox reaction. Reduction, oxidation taking place simultaneously, which is called as redox reaction. Now see what is redox reaction in terms of electron transfer. We have been learning that an element, when it loses its electron, it gains a positive oxidation state. That is, whenever we talk about alkali metals and alkaline earth metals, we used to know that they lose 1 or 2 electrons to get a positive oxidation state and they are called as cations. Similarly, we know when we come across the period, that is towards the p block elements, those non-metals especially, they gain electrons to become an anion, that is they get a negative oxidation state. Now let us consider the simple example where the formation of sodium chloride is concerned. Here sodium combines with chlorine to form sodium chloride. So what is happening here? Sodium is losing electrons to become Na+. Sodium atomic number is 11, we know. So when it loses 1 electron, it becomes octet. It forms a stable configuration and it becomes a cation, that is Na+. What happens with respect to chlorine? Chlorine gain those electrons and becomes a negative ion, that is an anion. So this is a reaction where there is a loss of electron and also gain of electrons. If you see, sodium oxidation state is 0 here. From 0 it has gained plus 1. There is an increase in the oxidation state with the loss of electrons. I would rather say sodium has got itself oxidized. Sodium metal has oxidized to Na+. So what is happening to chlorine? Chlorine here it was 0 and it became minus 1. There is a decrease in the oxidation state with the gain of electrons. So gain of electrons nothing but chlorine has got reduced. Now the sodium which is getting oxidized will be acting as a reducing agent. What is the role of sodium? It actually is getting oxidized, but it itself will act as a reducing agent. Means it helps the chlorine to get itself reduced. So what is the role of chlorine? Chlorine undergoes reduction, but it acts as an oxidizing agent. That is, chlorine helps sodium to get itself oxidized. So a good oxidizing agent will undergo reduction and a good reducing agent will undergo oxidation. The next example, if you see, sodium combines with sulfur to form sodium sulfide. So similarly the same thing happens here. Sodium loses electron to become Na+, sulfur gain electron to become S2 minus. We put here Na2 to balance the charges, because we have learnt in redox reaction that the number of electrons that are lost should be equal to the number of electrons that are gained. That is, the loss of electrons should be equal to the gain of electrons. So the electrons number should always be tallied. It should always be the same. So that is what we have learnt in redox reaction. The next, if you see sodium chloride formation, let us talk about the half cell reaction. What are half cell reactions? I am going to consider only the reaction that is happening with respect to sodium. What is happening with respect to sodium? Sodium metal becomes Na+ by losing 2 electrons. It actually loses 1 electrons. To balance the charges, that is the number of electrons lost and gained, we balance the equation with multiplying by 2. So sodium loses electron to become Na+, chlorine accepts the electrons to become Cl-. These are called as the half cell reactions or half reactions. So in proper definition of oxidation and reduction, apart from the 4 definitions that we have learnt, oxidation can be referred as loss of electrons, reduction can be referred as gain of electrons, or I can also say an oxidizing agent should be an acceptor of electrons. If you see here, this undergoes oxidation. Sodium is undergoing oxidation. Chlorine is a reducing agent. Oxidizing agent. So this oxidizing agent is what it is doing. It is accepting the electrons, that is gain of electrons. And when chlorine is undergoing reduction, sodium is an oxidizing reducing agent. So reducing agent should be a donor of electrons. Sodium is a reducing agent. It is losing electrons. It donates electrons. Chlorine is an oxidizing agent. It should be an acceptor of electrons. So these are the definitions for oxidation, reduction, oxidizing agent and reducing agent. So we have learnt till the 4 definitions. Now we will learn about the competitive transfer that is happening in electrochemical series, which we have already learnt in our 10th standard. So let us just learn in detail exactly what is happening in an electrochemical series with respect to our redox reactions. Children, now we were seeing about the electron transfer that is taking place in the redox reaction, and what are oxidation, reduction, and what is an oxidizing agent and what is a reducing agent. Now to be more specific, when we were talking about electron transfer, we have competitive electron transfer which takes place in electrochemical reactions. That is, in electrochemistry, we used to study in 10th standard about the series of metals which are arranged in the decreasing order of their reactivity. If you can remember children, we have some 12 to 15 metals which are arranged in the decreasing order, where hydrogen was kept as a reference metal. And that hydrogen element used to help us to identify which are the metals that can have higher reactivity or that can displace hydrogen, and which are the metals which cannot displace hydrogen. So, the highly reactive metals will be displacing the low reactive metals. So, that is how we used to compare in a given set of electrochemical reaction where two metals are given. We used to compare their reactivity using the electrochemical series, also called as the reactivity series. So, the reactivity series was helping us to know which metal can displace the other metal. So, there we also learned that the highly reactive metal can displace the less reactive metal, thereby the more reactive metal will undergo oxidation with a loss of electrons, and the less reactive metal will undergo reduction with the gain of electrons. So, these were the simple things that we learnt in 10th standard. Now, do we know that was under the consideration of redox reaction? Because there, when we talk about the loss of electrons and the gain of electrons, we simply learnt about displacement reactions, and that is also called as redox reaction. We were not learning in detail about redox reaction. So, here when we talk about redox reaction, definitely we should know how those reactive metals were able to displace the less reactive metals, thereby undergoing oxidation and reduction simultaneously. Because I just told you, any oxidation reaction happening, it can never happen without a reducing agent, which means reduction also happens simultaneously. So, there whenever there is a reduction reaction happening, there should also be an oxidation reaction happening in that reaction. So, here let us consider a beaker where we have copper sulfate solution. As we already know, copper sulfate is blue in color. So, this copper sulfate solution, when a zinc rod or a zinc strip is placed inside the beaker, what happens? In the reactivity series or in the electrochemical series, zinc is placed above copper. So, that shows that zinc is more reactive than copper and it can displace copper. So, what happens here? When zinc is displacing copper, definitely zinc will start losing electrons and it will form a zinc 2 plus ions. And what will happen to the copper 2 plus ions in the solution? Those copper 2 plus ions accept the electrons from the zinc, get itself reduced and get deposited on the zinc rod as copper atoms. So, later after the whole electrochemical series is completed, there will be a reddish deposit that is happening in the zinc rod. So, the overall reaction can be written in an equation form: zinc plus copper 2 plus. Why we write here solid and aqueous? Because that is the state of that particular substance during the electrochemical reaction. So, zinc plus copper 2 plus will be giving zinc 2 plus plus copper. So, there we can easily understand zinc was at a zero oxidation state, but when it lost 2 electrons, it gets itself oxidized to zinc 2 plus with an increase in the oxidation state of plus 2. So, zinc undergoes oxidation with the loss of electrons. So, what is happening to copper then? Copper 2 plus in the copper sulfate solution gain those 2 electrons and get itself reduced to copper solid. So, zinc is undergoing oxidation, copper is undergoing reduction. So, zinc will act as a reducing agent and copper will act as a oxidizing agent. So, that is with respect to zinc and copper sulfate. Now, imagine the same solution if you place copper in zinc. If you place copper in zinc, what happens? The reaction does not happen. What could be the reason? Because when I take a zinc sulfate solution and when I dip a copper rod, copper being less reactive than zinc cannot displace zinc from the reaction. Being less reactive, it cannot undergo oxidation. So the whole reaction is not feasible. Now if you are going to consider another set of reaction where we have copper and silver. So when you take a silver nitrate solution and if you dip a copper rod, we can easily find that copper lose electrons to become copper 2 plus and silver plus ions in the solution gain the electrons and get reduced to silver atom. So here copper undergoes oxidation with the loss of electrons and silver undergoes reduction with the gain of electrons. Any reaction that we write with respect to oxidation and reduction in a redox reaction definitely is under the perspective of electrochemical series. Electrochemical series give us an exact definition for the arrangement of the metals in the decreasing order of their reactivity. So here we are considering 3 different metals. We have zinc, copper and silver. When you consider all the 3, we find zinc being more reactive than copper, which is again more reactive than silver. So silver being the least reactive, zinc being the more reactive. So once we know the electrochemical series, definitely we will be able to write the reactions with respect to oxidation and reduction. So that is what is with respect to the electron transfer in electrochemical series. Now let us learn something about oxidation number. Some important terms which are considered for a redox reaction. It is oxidation number. We have come across this oxidation number. We used to call it as oxidation state. We used to find out the oxidation state also. So let us consider a simple example which is the most common reaction that we have learnt. Hydrogen combines with oxygen to form water. So when you consider this reaction, we know hydrogen loses electron to become H2, that is with from 0 oxidation state it becomes +1 oxidation state where there is an increase in the oxidation number, and when you consider oxygen it gains the electrons to become a anion, that is the oxidation number changes from 0 to -2 where there is a decrease in the oxidation state. So hydrogen is getting oxidized and oxygen is getting reduced here. So there is a shift of electrons actually happening from hydrogen to oxygen. How do we define in simple terms? Oxidation number is a process where there is a complete shift of electrons from a less electronegative atom to a more electronegative atom. When you consider this H2O, we know oxygen is more electronegative than hydrogen. So definitely during dipole moment also we have learnt the more electronegative atom has a tendency to pull the electrons towards itself. It has a tendency to attract the electrons towards itself from the less electronegative atom. So as of hydrogen and oxygen is concerned, oxygen being more electronegative, it tends to attract the electron from hydrogen. So there is a shift, a complete shift of electrons from hydrogen to oxygen. So when you consider the same example with hydrogen and chlorine, what happens here? Hydrogen combines with chlorine to form hydrogen chloride, or we would say hydrochloric acid. So hydrogen bears a 0 oxidation state here, chlorine almost 0. Here in HCl, each of them having a +1 and a -1 oxidation state. So this +1 or 0 that we consider on the notation, we call it as an oxidation state. So what is an oxidation number? It denotes the oxidation state where the electron pair in a covalent bond belongs entirely to the more electronegative atom. Understand the meaning, children? The more electronegative atom will be having the electron pair with itself. if I have a compound with HCl or H2O, the electron pair that is between the HCl or H2O will be considered as that it entirely belongs to the more electronegative atom. So, if it is H2O, oxygen will contain the entire electron pair. If it is HCl, chlorine will be having the entire electron pair. So, that is the definition for oxidation number. So, that is given in your textbook. So, definitely we should be knowing about it. We have certain rules to learn about the oxidation number. So, that we will just quickly revise the rules that are there to define it. And what is an oxidation number or an oxidation state? So, we have certain rules, because any compound that is given to us, it is not that easy to find out the oxidation state of that element. So, we have some rules which we need to follow to assign the oxidation state of an element. So, let us just see what are those simple rules we need to follow. The first rule says that elements which are in the free or uncombined state have an oxidation state of 0. Which do not combine with any other metals, which is always available free in the nature, that is in uncombined form, they have an oxidation state 0. So, we have the elements like hydrogen, oxygen, P4, S8. So, these are some of the examples. Next, ions of one atom, the charge of the ion is the oxidation state. Like when I say sodium loses an electron to become Na+. So, this Na plus 1 denotes that it has a +1 oxidation state. When I say Fe3+, that shows it has a +3 oxidation state. When I say Cl-, that shows it has a -1 oxidation state. Oxygen is an atom which has a -2 oxidation state in almost all its compounds. There are very few exceptions where oxygen shows -1, -1/2, +1 and +2 oxidation state. Those are difluorides, superoxides or peroxides, where oxygen shows a positive oxidation state also. Similarly, hydrogen oxidation state is always +1, being an electropositive element, but when it combines with metals, we know hydrogen can combine with lithium, calcium, barium, magnesium. So, when it combines with metal, it forms hydrides. When it combines with metals to form hydrides, hydrogen bears a negative oxidation state. So, being positive metal, it can also show a negative oxidation state. Likewise, fluorine, chlorine, bromine, that is the 17th group element called as halogens, always show a -1 oxidation state, but the exception comes when chlorine and bromine combines with oxygen, which is more electronegative, or when I say that is chlorine and bromine being more electronegative, it starts bearing a positive oxidation state. The algebraic sum of the oxidation number of all the atoms in a compound should be 0. So, when I take a compound, when I add all the oxidation states of all the atoms in a compound, it should be equal to 0. But when I consider a polyatomic ion, like when I say carbonate or nitrate, NO3-, where I have a charge written on the top of this ion, so the charge will be equal to the algebraic sum. That is, after adding all the oxidation number of the atoms, that is not be equal to 0. Instead, that will be equal to the charge of this ion, that is polyatomic ion. There is a method to denote the oxidation number. Rather than putting it by -1 or -2, we call that method as stock notation. Notation means representation, or I can say the method of writing the oxidation state. So, here when I write stannous chloride SnCl2, I write here Sn within square bracket, I put the Roman letter 2 and I write here Cl2. So, this is stannous chloride, this is stannic chloride. So, these are the methods of writing the same compound in the stock notation form. So, if you see the definition that is given in your textbook, oxidation, an increase in the oxidation number of the element, because when you say there is always the loss of electrons, the number increases, the oxidation state increases from 0 to +1, +2, +3 and so on. Reduction, there is a decrease in the oxidation state. An oxidizing agent which can increase the oxidation number of an element are called as oxidants. So, we call the oxidizing agents as oxidants. Reducing agents lower the oxidation number and you call them as reductants. So, reactions which involve the change in the oxidation number of the interacting species, we call those reactions as redox reactions. So, that is how redox reactions occur in the nature. So, now we are going to learn about some of the reactions that are involved in this chapter. Let us now learn about some of the types of redox reactions. The first type is called the combination reaction. So, when I say combination, it is nothing but 2 or 3 things are going to combine together to form a complex compound. Simple molecules, they combine to give a complex molecule. So, if you see here, the reactant side, we will have more number of reactants and there will be only one product. So, like A plus B giving C. So, this is a combination reaction. A simple example I can write, carbon plus oxygen giving carbon dioxide, or methane plus oxygen giving carbon dioxide again. So, these are some of the examples where there are reactants which are combining together to form a complex compound. So, here if you see, carbon bears an oxidation state of 0, oxygen is also 0, but once they form the product, they have carbon losing electrons to become +4, oxygen gain those electrons to become -2. -2 into 2 is -4. So, total oxidation number becomes 0. So, this is an example in the textbook. Every reaction has been given several examples for you to learn. The next one is a decomposition reaction, which is an opposite of combination reaction. What happens here? There is a breakdown of the compound to 2 or 3 components. The complex compound, it splits or break into 2 or 3 components. Say let's take water. Now, water splits into hydrogen and oxygen. If you see, water has an oxidation state of +1, oxygen is having -2. When it splits or break into its individual atoms, there it will be in the elemental state of 0. So, that shows that it is a decomposition reaction. Not all the decomposition reactions are redox reaction. If you see, even the decomposition of calcium carbonate giving calcium oxide and carbon dioxide, it is not a redox reaction. Now, the third type is a displacement reaction. See children, this we have learnt in our 10th standard, displacement reaction in reactivity series chapter. The high reactive metal displaces the less reactive metal. So, if you consider x plus yz, it gives xz plus y. In this, we have 2 types of displacement. We have metal displacement and non-metal displacement, where a metal displaces another metal. Copper sulfate, when it reacts with zinc, it forms zinc sulfate and copper. Zinc, from its 0 oxidation state, loses electrons to become +2. Copper, from the +2 oxidation state, it gains electrons to become 0. So, that is how the real oxidation state plays here, by increasing and decreasing in the oxidation number. The next one is a non-metal displacement, where the alkali metals and alkaline earth metals try to displace hydrogen and oxygen from the solution. If you see, sodium, which is more reactive, reacts with water, displaces here hydrogen from that, and there it forms sodium hydroxide. And if you see, zinc reacts with HCl, displaces hydrogen here to become zinc chloride and gives out hydrogen gas. So, these are some of the examples of non-metal displacement. Several reactions have been given in the textbook with explanation again. So, I am not taking all the examples here. You can just read out the examples along with the explanation that is given down. Now, let us get into the last type of redox reaction, which is disproportionation reaction. Yes, now let us learn about the fourth type of redox reaction, which we call it as a disproportionation reaction. What does it mean? Disproportionation means element in one oxidation state will simultaneously undergo oxidation and reduction. That is, the same element can undergo oxidation and it can also undergo reduction. So, there will be a loss of electron and gain of electrons by the same element. In such reaction, an element can exist in 3 oxidation state, that one particular element will possess 3 different oxidation state. Consider the simple example, hydrogen peroxide giving water and oxygen. So, if you see oxygen in hydrogen peroxide bears a -1 oxidation state, which will become -2 in water and become 0 in its elemental form. So, there you can see there is an increase in the oxidation state and also a decrease in the oxidation state, which shows that it itself undergoes oxidation and reduction simultaneously. So, the same element, when it itself is oxidized or reduced, we call such reactions as disproportionation reaction. Now, when we learnt about all these chemical equations or reactions, now there are some complex reactions which need to be balanced. And when we write the half cell reactions, we always make sure that the number of electrons lost should be equal to the number of electrons that is gained. So, when we talk about balancing the number of electrons, we should make sure that the whole reaction is getting balanced. So, such balancing the equation is done using 2 different methods. The first method is change in the oxidation state of the reducing and oxidizing agent, and second one is splitting the redox reaction into the half reactions, where one reaction represents the oxidation half cell and the second reaction represents the reduction half cell. So, these are the 2 methods which we will be learning one by one. Types of redox reactions. Redox reactions are of 4 types: combination, decomposition, displacement and disproportionation. Let us learn each of them one by one. Combination reaction. In a combination reaction, 2 reactants, at least one in elemental form, combine to form a compound. Let's take an example. All combustion reactions are combination reactions. Decomposition reaction, in which a compound breaks down to form 2 or more components, out of which at least one is in elemental form. Decomposition of water is an example where hydrogen and oxygen are the products with different oxidation state. Not all the decomposition reactions are redox reaction. Calcium carbonate giving calcium oxide and carbon dioxide, where the oxidation state of all the atoms do not change. Displacement reaction. In a displacement reaction, an ion or atom in a compound is replaced by an ion or atom of another element. Such reactions are called displacement. It is of 2 types: metal displacement and non-metal displacement. In a metal displacement reaction, one metal in a compound is displaced by another metal. You can see the example. In non-metal displacement, displacement of hydrogen from water and acids. Last, disproportionation reaction, a special type of reaction in which an element in one oxidation state is both oxidized and reduced. Here, the element which is getting oxidized and reduced will be having 3 oxidation states, and it will be in an intermediate state having a lower oxidation state and a higher oxidation state. Let us look at this example. hydrogen peroxide giving water and oxygen. Here oxygen has an oxidation state of -1, 0 and -2. We are going to learn how to balance the redox reaction using the first method, that is oxidation number method. It's a very simple method, children, and often asked in our exam. See, I'll just read the question. It's given that write the net ionic equation for the reaction of potassium dichromate K2Cr2O7 with sodium sulfite Na2SO3 in acidic medium to give chromium ion and sulfate ion. So this is the question given. Definitely you will be given this equation in your exam, so you don't have to worry about it. Okay, they have told dichromate ion combines with sulfite ion to give chromium ion and sulfate ion. So this is my reaction I have written, that is my step 1. What is the step 2? Assign oxidation numbers, because this is an oxidation number method. So I have to find out the oxidation number of each element present in each ion that is present in the equation. So first let me take this dichromate ion. I know oxygen's oxidation state is -2. With that there are 2 chromium ions. So 2x minus 2 into 7 equal to -2, which is the charge of the whole ion. So 2x minus 14 equal to -2, 2x equal to 12 and x equal to +6. We already know how to find out the oxidation state. So chromium has +6 oxidation state in dichromate ion. Next, let us move to sulfite. In SO3 2-, we need to find out the oxidation state of sulfur. X -2 into 3, because there are 3 oxygen atoms, equal to -2, which is the charge of the sulfite ion. So x minus 6 equal to -2, x equal to +4. That shows sulfur has +4 oxidation state in the sulfite ion. Then next we need to calculate the oxidation state of sulfate ion. X -2 into 4, because there are 4 oxygen atoms, equal to -2, which is the whole charge. So x equal to -8 equal to -2, x equal to +6. So the charge of sulfur in sulfate ion is +6. After writing the charges, that is putting the charges of each ion on its top, we understood that chromium has got a decrease from +6 to +3 and sulfur has got an increase of +4 to +6. So there is a decrease of -3 and there is an increase of +2 in the oxidation state. So what is the next step we need to do? We always know that the number of electrons lost should be equal to the number of electrons that is gained. So I need to balance the charges. How should we balance the charges? Now we will see the next step to balance the charges. So we have come to the third step, where we have written here where chromium get reduced with an oxidation state of +6 to +3 and sulfur with an oxidation state of +4 to +6. So there is a decrease of -3 and an increase of +2. As we know, the charges should be balanced. To balance the charges, I multiply -3 into 2, that is becoming -6, and 2 into 3, that becomes +6. So both the side it gets balanced. So once I multiply this, I put 3 here, 3 here and 2 here, I get a equation like this. What is the next step? In the question it is written that this happens in the acidic medium. So in the acidic medium we need to count the number of oxygen atoms. The charge of the oxygens, if you see, it is actually we have -2 here and -2 total. We need to add 8 H plus ion so as to make the reaction becoming equal. So you have -14 again, and here 3 into 2 -6, okay, which is becoming -20, and here it is again 4 into 2 -8. So when it is 16 is the charge difference of LHs and RHs. 16 oxygen atoms is nothing but 8 H plus. That is 8 H plus will be adding on the left hand side. Whenever it is an acidic medium, H plus should be added on the left hand side. So what is the last step? When there is an acidic medium where H plus is added, the corresponding water molecules need to be added on the right side of the reaction. Since there are 8 hydrogen ions, it should be 4 water molecules, the half of it, because 4 into 2 becomes 8 again. So again, to balance the charges, we put 4 water molecules. So this is the final equation, which is a balanced chemical equation. We are now getting into the next method of doing a balancing of redox reaction, where we have half reaction method. From the name, it's very clear that the whole reaction is splitting into 2 half reactions, out of which one is an oxidation reaction, the other one is a reduction reaction. Step 1 is we write the unbalanced equation. See, in the question it is given, I'll just read out the question for you. We have to balance the equation showing the oxidation of Fe2 plus ion to Fe3 plus ion by dichromate ions in acidic medium, wherein dichromate ions are reduced to Cr3 plus ions. Page number 275. So for the first step is we have written Fe2 plus combining with dichromate ion to form Fe3 plus and Cr3 plus. What is the step 2? We need to split the reaction into oxidation and reduction reaction. So which is my oxidation reaction? Fe2 plus getting converted to Fe3 plus. So I have written that reaction. So which is my reduction reaction? Dichromate ion, where chromium bearing a +6 oxidation state get reduced to +3. So that shows my reduction reaction. Then what is the next step? We need to balance the atoms other than oxygen and hydrogen. So other than oxygen and hydrogen, if I see here in oxidation, both are having only one Fe plus, that is iron ions. Here I have 2 chromium, but in this only 1 chromium is there. So I multiply this reduction reaction by 2. So 2 into Cr3 plus. So once I multiply, this will be my reduction reaction. It is clearly mentioned that the reaction takes place in the acidic medium. So when the reaction is taking place in acidic medium, we need to add water to balance the oxygen atom, and we need to add hydrogen H plus ion to balance the hydrogen atoms. If you see this first reaction, children, I have 7 oxygen atoms here, but I don't have oxygen atoms on my right side. That is 7 2s are 14 O oxygen ions are present here in this reaction. So to balance that, what I will do, I will add 14 H plus, which is nothing but I am going to add water molecules to balance the oxygen atoms. I need 7 oxygen atoms on my right hand side. There are 7 oxygen atoms here, but right side I don't have any oxygen atom. So I multiply by 7 water molecules. So I get 7 2s are 14 hydrogen, 7 into 1 oxygen becomes 7. So now the hydrogen is less. So here I have 14 hydrogen, but here I don't have hydrogen. Since it takes place in the acidic medium, I will add 14 H plus. To balance the hydrogen on my right hand side, I add 14 H plus here. Now we will see how to go. So step 5 is Fe2 plus. We'll take the oxidation reaction. Now we have to look at the charges. To balance the charges, Fe2 plus loses 1 electron to become Fe3 plus. So you add 1 electron here so that the LHs become equal to RHs. Now what we will do, we'll count the ions. So that is dichromate ion plus 14 H plus gives 2 Cr3 plus 7 H2O. Before writing the 6 electrons, just count the charges here. Minus 2 on the left hand side, 14 into 1 is plus 14. So 14 minus 2 is 12, which is my LHS charges. What is my RHS charges? 2 into plus 3, which is plus 6. This is 0. So 12 minus 6 will be 6. So to balance the charges here, I add 6 electrons on my LHS so that my LHS and RHS become 6 and 6 equal. Now that is the reduction reaction is now with 6 electrons. What about my oxidation reaction? So we multiply the oxidation reaction with 6. So what do we get here? 6 Fe2 plus gives 6 Fe3 plus 6 electrons. Now add this reaction and this reaction. When you add all the reaction, you get the 6 electrons and 6 electrons getting cancelled. So what do we get here is 6 Fe2 plus dichromate ion plus 14H plus gives 6 Fe3 plus 2 Cr3 plus 7H2O. So this is a balanced redox reaction. This is how we will be learning. Children, you have several examples given in your textbook. Please look at those examples and try to do the problems. Okay. Next to page number 277, we have redox reaction on the basis of titration. It's not that important. You just go through the points which are given. I'll be posting the video along with this. And then you have redox reaction as in electrode process. If you remember this, zinc and copper, which we have done already in our 10th standard, zinc dipped in zinc sulfate, copper dipped in copper sulfate, anode and cathode. The same thing is given, explanation is given here, which I'll be posting a video for the better understanding. I'm not wasting the time in explaining the same thing which we have learned in our 10th standard, the first galvanic cell experiment. Okay. So with this lesson is getting over. Definitely when the videos will help you to understand better about each and every topic. So this I'll be posting the video which are related to these topics. Once you see the video, please write the notes wherever it is necessary. Okay. Thank you children. If you have any doubt, kindly call me. Thank you so much. Take care. Bye.